Hello, everybody. I want to first apologize for starting a bit late. I had a problem with the time difference, but I'm glad you could join us. My name is Dr. Jakob Ostake. I currently serve as the Assistant Vice President for International Affairs at Morgan State University, which is located in Baltimore, Maryland. This presentation is based on the work that I've done in my 23 years in the School of Engineering. I'm an associate professor of electrical and computer engineering. So this is work that we started back in 2008, 2009, and it's a journey that shows how we try to change how we teach electrical and computer engineering, education, especially when it comes to hands-on learning, both outside and inside of the classroom. So the title of my presentation is Hands-on Learning Without Limits, and this is our effort to improve engineering education, not only in the USA, but also in Africa, with a focus on Ethiopia, which is my home country. This is a brief overview of what I'm going to present. I'm going to talk about this, what we have called experimental centric pedagogy, which is a new pedagogy that we developed when we designed these portable kits. And I'm going to share with you some results we've done, we have received from universities, both in America, but also overseas. And then other examples of work. And of course, I'm going to finish with the work that I've done in Africa with a focus on Ethiopia, just to say that this is a technology and a pedagogy that will be very, very beneficial to universities that are in developing nations where there is a lack of equipment in the laboratory. Just as a background, Morgan State University is what we call a historically Black college and university. We are in Baltimore, Maryland, and we are more than 150 years old. Our size is, by American standards, is what we call medium size, about 8,500 students. And our research status is R2 high. So for your information, the highest research status in America is R1. So we are very, very close to becoming R1, which is the top. Only about 130 universities out of thousands of universities in America have R1 status when it comes to research production. And we have several PhD, masters, and of course, a lot of the bachelor's programs. We also offer both online and face-to-face programs. And this is a day where we're living in a global higher education environment, and Morgan is ready and willing to create partnerships and collaboration with universities around the world. And as you can see from my work here, we have a lot of partnerships. So this journey started back in 2007, 2008, when my colleague, his name is Dr. Don Millard, he used to be at RPI, Rensselaer Polytechnic Institute in upstate New York. He came up with an idea where he realized that his students were not tinkering enough outside of the classroom. This new digital generation, our generation, we used to open up old radios, we can see the electronics, you can try to fix some things. With the new generation, everything is, in a black box, and nothing is being accessible. So he wanted his students to have a lot of hands-on experience and tinkering outside of the classroom. So he developed his what you see in this red box, portable kit. At that time, it was revolutionary. He did that work with his PhD student. And by 2008, the prototype was finished. So we received a grant from the National Science Foundation to try this product for the next 5 years at least 5 different universities. And we were fortunate that Morgan State was one of them. So between 2008 and 2013, we tested this board. We also developed a new pedagogy, which we call experimental centric pedagogy. And at the end, this thing was very successful. In 2013, it was commercialized. The goal there was to make sure that the students have a portable lab kit that they can take home with them, so that when they leave the laboratory classroom and they want to do some hands-on tinkering, hands-on training, hands-on practice, they are not forced to come back to the lab, and they can be innovative and creative. And the great thing was that we made sure that the price of this product was below $250. It also works on USB power. So we try to make it as efficient as possible. And as you can see on the screen, this small kit over here on the right replaces about 5 or 6 big equipment. And this is a lab that we have set up at Morgan. This on the left is about close to $5,000 to $10,000, depending on the type of devices you have. And this kit, which is less than $250, when you connect it to a laptop, can give you the same features. So that was really an innovative product. And of course, this product was finally commercialized. And now we have companies in the US, but also around the world who have designed their own versions. We personally, initially, we used the analog discovery, but now since 2008, from 2013 to 2017, we use the analog discovery because that's the one that was only on the market. But now, since 2008, a lot of universities around the world, also in the US, have been using what we call the ADALM 2000. And these are amazing devices. If you just Google ADALM 2000 or 1000, or you Google analog discovery, you'll see where to purchase them and how to use them. But the key is we've used it since 2008, 2009, 2010 in high school outreach programs, middle school outreach programs, in addition to universities. So this product not only can be used for universities, but also can be used for outreach. And as you know, we want to recruit more young engineering students, so we use that technology. And as far as our concern is, we have to come up with a new pedagogy. And the key is, how do we make sure that students who have varying learning styles and learning background, how do we allow them to learn at their own pace and using their own environments? Because everybody doesn't learn the same way, but also our big emphasis was, how do we allow our students to do electrical engineering laboratory outside of the classroom? So of course, anybody who has an engineering program has to provide the lab equipment inside of the lab room, but this piece was to allow them to have this lab technology and pedagogy outside of the classroom. And it was very, very effective. And what we did now is, at Morgan, we have been using it since 2009, 2010. We teach most of our second and third year classes, also our first year classes. And in my case, as far back as 2010, I was using it to teach my electrical circuits lab course, which is a second year class, and also a third year lab course completely online in 2010. And what you're seeing here is, this is how students are using it in the classroom and outside of the classroom. And what you see here is a video conference. Now, at that time, there was no Zoom in 2010. So I was using Skype at that time, where my online student was demonstrating to me how she was building her circuit. And because of this portable kit, she was able to do all her lab experiments completely online. And so this is prior to COVID. Of course, when we hit COVID in 2019, all these boards were sold out because everybody around the world was trying to use them. But fortunately, at Morgan State, we had ordered enough of these boards, and we were able to use them outside of the classroom. So when COVID shut down the whole university, our students were able to use this portable kit to do all their labs completely online from their home in their dorm room. And we were able to successfully allow them to finish not only their theory classes, but they also were able to finish their laboratory classes completely online. So it was beneficial. In the US, we have a whole big community. It was more than 25 partners in 2018. I think by now it's close to 40 or 50 partners. And of course, we have a special grant with the HBCUs. We have a special NSF grant where we have 13 HBCUs, as you can see over here, who have decided to use the same technology and pedagogy in their second and third year classes. And so we have also universities all over the United States, and of course now all over the world, who are using this technology. The key is this, we're trying to make sure that as we teach engineering to our students, we don't take the old way of, doing some, take your math classes first, then you do a lot of theory, and then you lose the students, especially if a lot of these students want to do hands-on. You spend too much time on theoretical work, you might lose them. And then by the time you get to the experimentation or the simulation, they don't have the interest. So in this case, what we do is we jump straight into the experiment, because with these portable kits, we allow them to do hands-on. And then once we start tinkering and doing the experiment, then we start talking about the math behind the experiment, the model behind the experiment, even the simulations can be done. So what we're doing now is we're still covering everything that we usually do in a typical class, but except the order now can be easily switched back and forth based on the needs of the students. So this was really innovative. And the key here is that the technology was portable at that time. Yes. The grant, once again, for the historically Black colleges was from 2013 to 2017. And so it was very, very supportive, and we were happy to get that grant from NSF. And the key there is what happens to our students when we add experimentation in the curriculum on top of all the theoretical work that we're doing. And this is key, is we're trying to do experimentation outside of the classroom. So this is not just replacing the old labs that they do in the classroom. It's really taking the old labs and supplementing them with a lot of experimentation and hands-on outside of the lab. And that was the key for us. And for the type of students that we have in the historically Black colleges, it was very, very critical. So of course, we have to do a lot of workshops to introduce this concept to the faculty from 13 universities. We did a lot of training workshops every beginning of the semester. We also have internal and external assessment people who came and to make sure that the work is being done correctly and the assessment is done correctly. And of course, we also collected data over a 4-year period. And the key is, how does experimentation impact the learning of our students? So we have 4 ways of doing it. Precursor to learning. The question is, what happens when you do experimentation before they do the actual learning? And then what happens immediately after you do the experimentation? And then, of course, after these students have used this experimentation and this technology and pedagogy for a while, does it have a long-term impact on their learning in other classes? And of course, we have to document and facilitate everything. As you can see, that the students really like the fact that our instructors now, especially in their regular lecture class, instead of just talking lectures, they now can open their laptop. They can actually do some in-class demonstrations inside of the classroom without the need to have very sophisticated lab equipment. So the students love the fact that the instructors now can not just talk about theory, they actually can do some demonstrations, experimentations that they do. Also in the class, in the lecture class, then the students now can sit next to each other, they can open up their laptops, they can actually do some practicing, some hands-on work. And this is doing hands-on work in the lecture class. So this is now where we are changing what we talk about pure lecture versus pure lab. Here, the class becomes a combined. So when I was teaching this class, I don't have a separate class for the lecture, and I didn't have a separate class for the lab. We combined the lecture and the lab, and that allowed the students to be fully immersed in the concept so that they can start from theory and do the lab in one setting. And that way, they have a better impact on their learning. As you can see, the students, when we asked them, the lecture was their least favorite thing to do because they have to sit down and just listen to somebody talk. So they enjoyed the instructor demonstration. They also enjoyed the hands-on experimentation with the partner in the class. And of course, we also looked at what happens now to the students who use this technology and pedagogy. And as you can see, these dots show you how the students now were more confident in using improving their hands-on skills. Also, another thing we did is, instead of just giving homework problems where we tell them go to the back of the textbook and do this experiment, they do this homework, we actually gave them homework in the lecture class that included doing some building of circuits, testing of circuits, so that once they do the experimentation, then they're going to the back of the textbook and they actually do some homework. So it was very, very beneficial. Of course, when it comes to immediate learning, the students really appreciated the fact that they can actually do some of these experiments, discuss it with their classmates, and they can have an open discussion. So these are all the things that they could not do previously unless they were sitting in the lab. Now, what we're allowed to do is we took the lab from the lab room, and now we allow our students to be able to do not only theoretical work, but also hands-on learning anytime, anywhere, and with their colleagues. So when we talk about long-term transferable knowledge, they indicated that this tool allowed them to work more collaboratively, because at that time we didn't give one kit to each student. We didn't have that at that time, so they had to work in groups of 2 and groups of 3. So having this tool allowed them to force themselves to work together outside of the classroom more often than what they did previously. So as you can see, this tool was beneficial to them before they started learning the concept and the theory. And it was also beneficial to them to allow them to understand the theory much better. And then in the long term, they said that it was very beneficial because it increased their teamwork and other things. So very, very beneficial to them. Of course, they also indicated that after they finished my class, the first question was, can we use this tool in all the other classes in electrical engineering? Of course, unfortunately, at that time, in 2009, 2012, 13, and also beyond, we didn't have this technology and pedagogy in all the classes. But by the time we finished in 2017, we made sure that this technology was at least used in partially in all of the classes that we teach. Now, I'm not saying that we use this technology and pedagogy in every electrical engineering class we teach, but we try to use it in as many classes as possible after we finish training all the instructors. But the students said they benefited a lot from it. Of course, at RPI, which was where the lead institution is, they've done some amazing things. And my colleague, Dr. Ken Connor, has shared these slides with me. So similar to what we did at Morgan and other HBCUs, we do a lot of hands-on homework. And for us and for Dr. Connor, the key is, how do we make sure that we spend a lot of time when you look at Bloom's taxonomy in these top 3 levels? Because, the remembering and the understanding, it's good, but if they cannot do the analyze, evaluate, and create, which is the most important piece of learning, then the students are not taking something that is meaningful and something that is lasting with them. So we were able to do this thing with his class. And as you can see, he took his all labs, which we call alpha labs, which is your lab 1, lab 2, lab 3, typical labs. And then what he was able to do is that he took these 3 or 4 labs and he combined them into a more design-oriented lab that you can do easily with this technology and pedagogy. And now, instead of having a lot of labs which are separate, he was able to design it and make it together. So these are labs that now we're teaching now in first year and second year classes. Usually these advanced labs, we usually used to teach them in 4th year or your 5th year. Here we were doing it in the 1st and 2nd year. Of course, the students, had some challenges at the beginning because, like I indicated, the new generation of students are not used to tinkering, and they spend a lot of time on social media, watching YouTube. But now we are trying to force them to become more tinkerers and seekers of technology and knowledge. And of course, the biggest concern for them was we had to teach them how to troubleshoot because they didn't have those skills coming from high school. So it allowed us to adapt our teaching pedagogy, but also it made sure that our students adapted properly. So the key is in Africa, how did we do that? In Africa, as you know, there's a lot of brain drain that has happened, and also a lot of universities have limited funding to do equipment laboratories. So in my home country of Ethiopia, there was a problem because a lot of the universities don't have enough equipment to teach our students, especially when hands-on skills. You can teach, philosophy, no problem. All these other liberal arts majors are no problem. But when you're teaching engineering or the other sciences, you need to make sure that your students have some practice in addition to the theory, so that after graduation, they become job creators instead of job seekers. So I had 2 answers, 2 major projects in Ethiopia. I've done this work for the last 12 plus years. And this program was finally expanded to 29 universities in Ethiopia in 2019. As you can see, in 2020, we were hit with COVID, so we had to pause everything. And now after 3 years, we're going to resume in 2022, 2023. But I believe that this technology and pedagogy can easily be used all over Africa and all the other developing nations that need. Of course, even those who have advanced technology can also use this pedagogy to make sure that their students are doing experimentation outside of the classroom. So we did a lot of work since 2009. We started with 5 boards, but then we donated more boards as we got them through grants from Analog Devices. And we had 2 main focuses. One was to make sure that those universities who have enough lab equipment can use them in their lab from 2nd and 3rd year and 4th year. And then those who have good lab equipment, they use them in their 5th year senior design projects to allow their students to become more hands-on. So we, once again, just like we did in America, we also have to do a lot of workshops. So we run workshops, training, knowledge transfer from 2009 to 2012, 4 years straight. We did workshops at least twice a year to introduce these young faculty on the technology, but also on pedagogy. because a lot of these are young men and young women. But then when we saw the result after a couple of years, we were just amazed. So in the university in Addis Ababa, the fifth-year students usually, when they do their senior project, had limited access to equipment. So they always focused on simulation and theoretical work. But in this time, for the first time in the history of the university, we gave about 5 boards to 5 groups, and we told them you can keep the board for the whole semester. You can tinker with it. You can do a lot of testing. And these students now started designing some amazing technology work for their senior project. And even their advisors were really, really impressed that these students were open. Of course, they were all these experiments that they did in previous years, they would have done a lot of theoretical work and maybe some simulation to show that it actually works. But here, for the first time in their history, they were able to do real hands-on testing, hardware, software. So the students were amazing, and their faculty were also amazing. So we're very excited that we have continued that work. And of course, in the countryside of Ethiopia, there's very, very limited lab equipment. In some spaces, in some countryside universities, you have a student to lab ratio of 20:1. So think about how you can do an electrical engineering lab when you have 20 students per station. So in most cases, the instructor will do the demonstration and the students just watch. And using this new technology now, we were able to take this 20:1 ratio to down to 5:1, sometimes in some regions 3:1. So what you're seeing here on the left is like I indicated, the instructor of the class doing the lab demonstration, and the students have to just watch because they only have one station. After the donations and a couple of years of training, the lab was redesigned, and now, as you can see, every station has a laptop, every station has the lab kit. See, the laptop anybody can buy, the multimeter anybody can buy, but this is the board that was what they needed. And once you connected the board to your laptop, the laptop becomes now your instrumentation, and all these students now can do their lab, as you can see, in groups of 3, groups of 4, and this really significantly improved how they teach, and they have this technology and pedagogy in their 2nd and 3rd and 4th year classes. So it was very, very thing. Of course, this work was not done just by Morgan. I had a lot of support from my colleagues from the Global Engineering Deans Council and the International Federation of Engineering Education. All the work we do in Africa, we always collaborate with the AEEA. We also have formed the African Engineering Deans Council Association. So I strongly advise of those of you who are interested in doing this work. Of course, you can contact me directly, but if you want to do more advanced things, especially related to engineering education, I strongly advise you to join the IFES, the International Federation of Engineering Education Societies. We do a lot of workshops free of charge, a lot of conferences you can attend. Of course, our next big conference, annual conference, for the first time on the ground, face-to-face, after COVID since 2019, will be the conference in Cape Town, South Africa, from 28th November to December 2022. So we're excited that we'll be there. So please join us. Of course, in Ethiopia, we've done some great things. I've done a lot of conferences in Ethiopia, supporting and making sure that the faculty and the universities in Ethiopia are greatly connected with faculty and other members. And of course, the best part for me was, after using this technology and pedagogy for 5 years in Ethiopia, the Ethiopian university faculty and their students were able to design their own mobile studio board. And this is really where I was really happy that after a 4 to 5 year experimentation and knowledge transfer, the Ethiopian students and the Ethiopian faculty were able to design their own hardware and their own software. Of course, this hardware and software is not ready for mass production or commercialization, but I was really impressed with the fact that they learned from how the boards that we gave them, the prototype boards, and then they were able to do that. So this shows that the students in Africa and other regions of developing world can do as well as any other student around the world if they're given the opportunity. Of course, we're doing extremely work, and now how do we expand and augment this? So we have a lot of activities now. The first part is, of course, we are partnering with Kwanzaa, which is a leading organization and a company that is based in Toronto. what they're doing now is they're taking our portable kit and they're augmenting it with advanced equipment and also technology and pedagogy. So I strongly advise you to contact them. Their website is listed here. They do a lot of mechatronics and IoT work. And what we're doing now is we also, when it comes to the pedagogy training, we are partnered with Purdue University. One of my colleagues, she's there, she's an associate professor, and they do pedagogy training on student-centered learning and problem-based learning. And of course, we do a lot of also training. So we have a lot of partners that allow us to expand this work. And of course, we have also through the IFES and the GEDC, we have a lot of activities with peace engineering. This is from University of New Mexico. This is just to show that we are doing a lot of great things. And of course, we're also working on making sure that the universities in Africa, in West, North, East, and South Africa are working together to expand their partnership. So we're very excited. We're doing a lot of great things. And of course, like I said, Morgan is ready to partner with you, and we're looking forward to giving any assistance to any institution or any organization that wants to work with us. And I really appreciate your time. Of course, we have, if you need any additional information, you can email me regarding anything that you have, but also if you have more specific questions, Dr. Connor, of course, he's retired now from RPI, but he still enjoys answering questions to colleagues who are interested in this technology. So this is it from me. I really appreciate your attention to my presentation. Once again, I want to apologize for the delay. I think that with the few minutes that is left now, I'll be more than happy to answer any questions from anybody. I think we have about 15 minutes before the end of the session, so I'll be more than happy to answer any questions from anyone. So thank you so much for your time and your attention. And now I'm going to be ready to answer any questions. You're muted, Koza. You're muted.
It's nice to meet you. Thank you, Professor Yacoub, for your nice presentation on hands-on learning without limits. And basically, from your presentation, we came to know how we can bring the life in our classrooms that experience can learn by doing. If we can make our classroom a lively environment, then a student can easy to understand the things. They can retain the knowledge for long times.
Yes.
And as well as they can think, they can critically think how to solve a particular problems, and as well as sometimes because of the environment they can create something new for themselves and for the others also. Benefits are abundant if we can ensure the hands-on learning in the classroom, and especially if we consider the COVID situations. Then,
yes, COVID. Yes.
During these situations, so especially in 2020-21, most of we were detached from our classroom.
Yes.
And the hands-on learning, importance of hands-on learning was very high in that particular situations. But still, we have the requirements for this type of pedagogy in our learning. And actually, if you consider bringing this technology or bringing these facilities in African countries as well as some Asian countries, then actually there are some differences. We are usually habituated with the classroom teaching, where lecturers are telling something, explaining some topics in a particular course, and students are only there, the receivers. But if we can ensure the availability of low-cost portable instruments in the classroom, that will benefit our students in diversified ways.
Yes.
So let us see whether there are some questions in our Vertex live chat, so that we can share with you. And
Yeah, and once again, I want to apologize with the time difference. I had UTC -2, -4.
okay,
I thought I was starting 2 hours later, and so
that is the problem.
yeah.
So perhaps they after a long wait they have left, and
Yeah, I'm sure they have left because I
I
don't
am
expect anybody to sit for 45 minutes waiting for the presenter to come. So I don't expect anybody to answer, but I'm sure that you have recorded this video so you can share it on your
yeah,
website. And I knew this was going to happen. Then you don't know how many people I asked, please tell me the time in Eastern time. And the answer that I got was I
yeah.
got two different answers from two different people. And and this is not the first conference. This is the second conference that I missed. The first one I missed completely because the time difference was 6 hours and I was traveling overseas and they didn't tell me what time it was. So I missed it. But like I said, most of the audiences, they might have gone to another session. But as long as the video recording is available, you can share it with them. And hopefully if participants have questions in the future, they can email me. But I'm glad at least that you were able to record the session and then you can make it available on your website, and anybody who's interested can watch the video, and then if they can have any questions, they can email me. Okay.
So as we don't have any questions, so what we can do now?
Yes, I mean, like I said, maybe you can tell me about yourself. What is your background? Are you an engineer by training, or where do you work?
Actually, I am, and my background is business.
Okay.
I completed my BBA and MBA in marketing and PhD.
Okay, congratulations. That's good. Yeah. Where are you located now?
I am from Bangladesh. You know Bangladesh?
Malaysia?
I'm from Bangladesh.
Oh, you're from Bangladesh. Okay. Okay.
Bangladesh.
Okay. So are you attending this conference from Bangladesh?
Yeah, I am from
No
Bangladesh.
problem. No problem. Yes.
You are from USA, right?
Yeah. Yes. Yeah. I'm in Maryland. Maryland. Yeah. Maryland.
Maryland.
Yes. We're like 1 hour from Washington, D.C.
Yeah. So maybe your origin is Ethiopia, right?
Origin is from Ethiopia. Exactly. Yes. But I came to USA to study, and then I stayed here after my graduate studies. But I go to Africa and Ethiopia at least 3 to 4 times a year. I still do a lot of training, workshops, capacity building. So I go back and I try to give back as much as I can.
So maybe you are.
Now, I've not come to Bangladesh. I've been to India at least 3, 4 times. I've been to China, but I've never been to Bangladesh. I've been to Malaysia, Singapore, but not Bangladesh. So maybe in the future, we might be able to
The
see each
next
other.
time, if you visit the Asian countries, then you are most welcome to Bangladesh.
Yes,
And
yes.
we will be happy to visit you.
No problem, no problem. Yes, so I'm like you said, most probably the audience, I don't blame them. Whoever signed up, they have moved on to other sessions because I don't expect them to sit for 30 minutes, 40 minutes, but just send my apologies to the organizers. At least the recording is there so you can share it. And I'm sure that those who are really, really interested will find the video, watch it, and then if they are interested, they will contact me. But I appreciate your patience and waiting for me. And I wish you guys a big success in your conference. I know it's a 3-day conference, so hopefully next time I will make sure that I have the right date and the right time. I had the date correctly, but the time, I'm still having a problem understanding all these time differences. And the problem for me is I don't know where they're running the conferences from. Because
Actually, our university representative, she has made the things easy for us. She has converted the time into local time.
Yeah, nobody did that for me. I emailed the organizers 3 times. One of them told me it's going to be in the 11 p.m. American time. That's what they told me, 11 p.m. American time. So I could have completely missed everything. And then again, I called them and I said, okay, I emailed them again. I said, please let me know what is the exact time, because UTC -2, I've never heard of that. I tried to do the conversion, and I did the conversion, and for
Conversion,
me,
huh?
yeah, I did the conversion online, and for me, I was supposed to present not now, but 2 hours from now. So I was relaxing, having my other meetings, and then I just happened to check my email, and one of them told me, "Oh, your session has started," and it was an hour ago. And I tried to join an hour late. It's a 2-hour session, but in any case, I think that's the advice that those people who are organizing these conferences, they need to put down Eastern time. In America, they can just do New York time. Tell us New York
Yeah,
time.
yeah,
This is
yeah.
it.
Just one time mentioning
It's one
is
time zone.
enough.
If you tell me New York time, I can find all the time
What
zones
is
in
the time
America.
now in Bangladesh? What is the time now in Ethiopia? We can
So
easily convert.
in America, right now in America, it's about to be 12 p.m. noon.
Yeah.
Okay, what time is it where you are?
Now it is 6 minutes to 10 p.m. in
Good.
Bangladesh.
So it's exactly.
Yes.
So I didn't know what time zone to use for me. So is the conference running on Indian, Bangladesh time? What time is it running on?
It started at 3 p.m. in our country.
Here. Okay, no problem. But in any case, it was great talking to you. Send my regards to the organizers. I hope once they see the video, they're gonna like it. But take care now.
Take care, and we are very happy to see you and having your lecture on this very important topic.
Yeah, so
And
you can send it to
hopefully,
them. Yeah.
hopefully the viewers will get the video very
Yes.
important for them as well as informative, and
All right.
perhaps they will able to practice these good things in their respective institutions.
All right. All right. Thank you, sir.
Thank you, sir.
Bye-bye.
Bye.
Bye-bye.
Bye.